Okay, so today we'll continue on from Thursday and um do basically a last iteration of pointers, right? This is basically you compare it to previous semester. There's a bit difference here because previous semesters I only have two lectures that cover pointers, and what I found is that there's typically not enough, I guess, demo and review into how to use pointers. So I hope this one additional lecture slot, along with a bunch of demos that we're gonna do today, would help you in terms of basically starting out these new concepts and making sure you have a comfortable um, control into basically how to use the memory address, how to use malloc, and everything else. All right. So let's us begin by quickly recap what we cover on Thursday, because to be honest, this is another a big topic, right? We talk about data structure using pointers, and the key here is basically because we can actually point to something, we have the address, and the address basically would give you the value and the ability that you can point to the next item. So we can use these concepts, right, to apply to anything that requires a next item. Something like a list, right? A list is defined by uh, every element can point to the next item that follow that element. And you can think of the multiple use cases of a list, right? You can keep appending new things to your list. It can create a collection. You can iterate over the list, right? And it would have this order in a strict way that the first item point to the second item, which then point to the third item, which then point to the fourth item, so on and so forth. So the general guideline is to make sure you can store the data elements as well as where you're going to point to, right? What you would do is to include a struct that have both the data node and the pointer that points to the next item, right? Then you declare a pointer that would point to the first item, something like a first in the front of the linked list or a root in the tree. And then you use the command malloc, right, to basically allocate a space for your node and append, right, to a new node. Again, we'll play with this more in our demo and assignments, right? And linked list in C is structured this way, right? Again, you have a struct node that consists of the elements along with the pointer, and the pointer types basically the type of what the pointer should be pointing at. It should be basically point to itself. The same type of this particular node, right? But you would then point to the next element, the node that have the next element, which then points to the next element, right? Which then again points to the next element. And again, at the end, you would say, hey, that's it for my pointer. You point to now, right? Because that's specified. That's the end of the pointer. And as usual, we have to have the front, right? That is basically, again, a pointer to this node type, right? That specified that's the first item in your collection. Any questions about the implementation of the linked list? From also whatever is on top of the demo we have from Thursday. Any questions, guys? So if there's a question, feel free to type it in. If not, I'm gonna move on. By the way, you can keep basically typing in a question. I'm gonna move on to the concept of how to implement the queue and the stack in C, right? Why are those important? Queue and stack are used a lot, right, in computer science. It's used a lot to basically even control your computer. It's used everywhere. And one of the common implementation of queue and stack is to use an array, right? The array acts like a buffer. How many of you here heard about the word buffer before? This word. Yes, no. So if you heard about this word before, right? If you heard about this word before, buffer means basically it's a space that you can store things, right? It's a space that you can store things. And when you have these buffer, right? When you have this buffer, it means that you can basically collect a bunch of items to be in your computer. You use a lot of buffers to process the next item, process the elements that are coming in. We use it, for example, to keep the incoming package from your network, right? You want to access Google, you would ping some the server so that Google send a packet back. You would buffer that. If you use the way the initial version, I guess YouTube, right? When you watch the video, you say buffering. Basically, this buffering also is a process to store this temporary data on the buffer so that it shows the video, while at the same time, it's actually downloads some of the new data from the internet, so it shows entire video without interruption, because that would be annoying, right? So you can use the queue and stack on top of these buffering concepts to implement a diverse type, right, of a way to collect and process the data. So if you want to do a kill, right, then you can basically have two indexes, one that points to the front of the queue and one that points to the back of the queue. And queue basically has two operations, enqueue and dequeue, right? Enqueue basically means I put another item on the back. So you put in a new item here, update the back index, so it essentially point to the new item that you just added. DQ means that I'm gonna take something out from the first item, update the index so that you have now the index points to the new front of the queue, right? And that was actually a great question coming Thursday on both sections about, hey, don't I have to delete the items I DQ? The answer is unless you want to make sure that particular item is protected and never be readable anywhere else, you don't have to delete it, because once the back loop around, right, loop around and comes back and point to this old item you deleted already, I mean, you basically overwrite that, right? There's no operation that somehow can read from the back. You can only read from the front, so that's okay. A stack, right, would be a little bit different. You put item in, right? So a stack. Again, you can implement this using an array, right? And you put item in from the top, right? So you have the index that say top, that point to the topmost elements, and you can push new item to the stack or pop whatever's at the top out of the stack, right? Self-explanatory. It's actually pretty simple, right? So you might run into a task that would ask you to implement these kind of structures sometime in the future, because it's actually, again, it's used a lot. The last thing we cover on Thursday is called binary tree, right? Anyone have questions about the high level concept of binary tree before I go digging into like how do you implement this in C? Because I want to make sure you got the overall concepts, especially for those of you who haven't taken their structure. So for those of you who haven't taken data structure before, think of a binary tree as almost like a linked list, but it can spawn two pointers that point to the left and point to the right, right? So the node, instead of having one single pointers that point to the next item, your next item can be on the left or on the right, which then can contain a node again that point to the left and point to the right, right? So that way you can actually branch out. This is one of the most common structure that used in computer science to actually maintain your data, and so that you can look it up quickly. You can kind of search your data inside this structure pretty quickly and a lot faster than a typical linked list. because instead of going through every single items, you would go to just these branches. So the step is typically logarithmic of the number of items in there. So it's typically faster, right? So now we talk about the overall concepts of how to build data structure. One remaining things that we haven't really talked about is can we combine, we talk about we can combine arrays of pointer, but we haven't really give some example of how to implement it, right? And one place that you would have to do that is on our assignment with the function that would calculate determinant of a metric, right? So today we'll go through some demo about metrics addition. There'll be in-class exercise. I'm gonna have a lot more time for your in-class exercise so that you can finish up all the in-class exercise, including the one today, because the one today will likely take the most time yet. And it's likely to be the one that takes the most time of the all in-class exercise. We would ask you to do a transpose of a matrix, right? So it's harder than other in-class exercise. It's slightly harder. The demo should help, and basically the more time should help as well. So I encourage you, when we said we'll move on to Discord and do the in-class exercise, come and join us so I can help you through the exercise. That would really give you the solid ground on how to use 2D array, right? So my first question is, how can I different a 2D array? So let's say I want to represent a 10 by 20 matrix. What are the different things you can do in C to create this 10 by 20 matrix? Any idea? Yeah, how do I declare a 2D array in C? How do I declare that in Python? Exactly, right? You can do int followed by the variable name, right? And then bracket 10 bracket 20, right? So that would create what? Is it a dynamic array or is it a static array? It's going to be a static memory allocation. You're going to get A, which point to a region of memory that basically is a giant chunk that has how many items in total. If I create 10 by 20, how many integer I can store in that whole big array? 200, right? It's 10 by 20. So multiply those is 200 items. They are actually contiguous in the main memory, in a sense that if you look at these elements, you will see that they are actually next to each other. What are other ways you can do this? Can you do something like a dynamic array? How can you do that? How can you declare a data type? Can you type it out on the chat? So is this valid? Can I do that? So what exactly is this? Yes, actually you're right? You got the row, but it's not what's in the row. Is that an integer in the row or is that something else? It's an array of pointer, you're correct, right? So what you get here is you get the variable A, which is an array, right? A is an array. And in here, is that an integer of, is that an integer or is that a pointer to something? What is the type of A? Each element of A is that int or int star? Yeah, this thing is int star, right? It's a pointer. So when I have an array of pointer, what can I do? What can I do? I can basically say, hey, this is going to be equal to malloc, a different array, right? This is going to equal to malloc, a totally different array. So I can do the same thing for all these elements, right? This is going to equal to malloc, different array. So each one of these pointer points to an array. So let's go back to our goal. Then can I create a 10 by 20 matrix using this? Yes. Yeah, you're correct. You can. Right? We can basically have an array of pointer. What about this? Double star. What is that? So what is A? It's a pointer to what? It's a pointer to pointer. So it's kind of like the location to your metrics, right? But it's actually not that. So what you do is star A, like double star A, you can basically kind of do the breakdown by this. Star A is a pointer. And star of that is an array of pointer, right? But this one, every single thing is dynamically allocated. So in the beginning, when you just declare this, it's not initialized to anything. So what do I have to do to use it? What do I have to do to use it? Yeah, step one, malloc, right? A is gonna equal to malloc, size of. So what is the size of each item in A? Is it int or is that a pointer to int? Yes, exactly. You're right. So it's size of int star, right? And let's say I want to do 10 by 20, I can multiply by 10. I got now what? What do I got out of this one line? Is an array of pointer to int, right? Which is almost exactly the same thing as this. It's an array of pointer. There are 10 items in there. And then step two, over here you have to loop. Then A of I is gonna equal to what? Malloc, right? Because you need the space for them as well. So you have to malloc for each A of I. Size of what? What do we put here? What is each item points to in A? To int, right? Now each element is an integer. Multiply by 20 because we want 10 by 20, right? So you might be asking the question of, well, there are, sorry about that, I write on top of each other, but the question is, what are the difference? What are the difference, right? You might be wondering what are the difference. So to explain that, let me go to the concept of a memory first. Let's just go and use this example of like a 2D static array, right? Which is this. So this static array, first of all, it's kind of local to the function. It's local to the function that you're using, right? So that's the first thing you have to understand. There's a concept like if I have things declared in your function, it's bind to that function. If someone else want to use it, you have to somehow pass that to another function. The second thing is when you bind memory, how do I organize the address? How do I organize the address when I have memory? So let's say this is my memory. How do I refer to each location in here? How do I assign the address for these physical location in your DRAM that you have on your computer? It should start with address what? No, address 0, right? To address n, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Everything is contiguous in this 1D long memory. So how do I store a 2D array in my 1D, one-dimensional address? How do I do that? Any taker? So let's say this is where I put a of 0, 0. Where should a of 1, 1 be? I mean, not 1, 1. Where should a 0, 1 be? Where should a 0, 1 be? Yeah, basically next to a of 0, 0, right? And this would be a of 0, 2. And let's say this is basically a of 0 and 19, the last elements of that row, right? Then where should a of 1, 0 be? Where should a of 1, 0? Basically, the next thing should be. It should be next to this item, right? So this goes here, right? So you can imagine this contiguous chunk, right? This whole thing that are next to each other start from a of 0, 0 up to a of what? 9, 19, right? The last element in your array. This whole 2D array is kind of being flattened out in this 1D space, right? Any questions so far on how this is organized in your memory? Because you keep going, basically. So first of all, please note that when you pass around this type of static array, it doesn't really play well with the handling of metrics, and we'll show that in the demo today when we do matrix addition. We'll show that to you. The next sample is, what about if I have this array of pointer, right? Let's say I have my memory right here, and this is my array A, right? This is A of 0, A of 1, A of 9. So each of these elements in A, what are the type of this? What is the type of each element in there? Yeah, in star, right? A pointer to integer. So let's say that A0 points to this location. So basically this is A of 0, 0 up to A of 0, 19. Where should A1 point to? When you do the second malloc, where should A1 point to? Do I have, okay, let me rephrase that question. Do I have do I have that guarantee that it's going to be next to A0? The answer is not. It can be because you call malloc, right? Malloc go and find the next empty space somewhere in the memory. So it can be here. A1, 0 to A1, 19. And this would point here. So if any free space in this wide range of space, right? So you can have the A9 suddenly point to here, right? It's going to be A9, 0 down to over here is A9 of 19, right? It can be anywhere in the memory. So this is basically the difference in how this can be organized, because every items here are pointers, right? And just basically point to somewhere in your main memory based on whatever malloc give you back. So there's no guarantee that they're gonna be next to each other. In many cases, they might because you call malloc back to back to back to back to back. But once you start using computer for a while, sometimes you have memory allocation everywhere, so your malloc might return something non-contiguous to you. A0 will be here, A1 will be another place, right? What about this? What about this? To be honest, this is kind of similar to the other case where you have the array of pointer, right? Oops, my bad. Similar to kind of when you have the array of pointer, but the difference, right? The difference is what? What are the difference in this case versus the earlier case? With the earlier case, can I expand the row from 10 rows to 20 rows to 30 rows? Can I do that through malloc and free? Exactly. Now you can dynamically resize, which is pretty good, right? It's actually a pretty good properties. You can like dynamically resize your array so that you can have any size, anytime, right? So how do I pass them around? To pass a 1D array is actually not that hard, right? So one thing you can do is to pass in the pointer. And that's it. You pass in the pointer to your function, and you can modify the function value, you get the correct results. However, when you have the 2D array, what you want to pass in is again the pointer in the double star format. This is pretty safe way to do it because when you use dynamic array, when you use 2D array, to be honest, unless you're dealing with C++, which in some cases they know how to deal with the row and column, let me ask you this function. How do the function that got my call know the size of my array? Right? So you typically also would pass in the size of the X and Y dimension so you know exactly how to parse in the array. And we can use pointer to pass them around. Again, we do this in the demo and to show you what can happen, right? So to pass one array, basically array is essentially pointers. So it has a starting address. So the static array already have memory allocated for them. So to pass in your array, you can do something like this, right? Vector add in star A in star B, right? And you can add them together. I forgot, to be honest, over here, I forgot where I'm gonna put in the resulting of the add, right? And be careful when you have star A and star B, you also want the size of your array because otherwise you're gonna loop and then go out of bound, right? So that will be segmentation fault. And we will do a demo for this to show how you can do vector addition. You can also pass a 2D array, right? You can pass in an array of pointer in this format, right? You pass in A and B. Like if I want to do a matrix addition, again, I forgot to add the resulting matrix that I want to add together into. Basically, if I want to do C equals A plus B, don't forget to have int star star C as the last input so that I can actually store the result, right? So to show this is the demo time. I'm going to show you three set of codes, right? But before we transition to my desktop so that I can type things on the desktop, any questions before we transition? Any questions conceptually before we go play around with the coding? Because otherwise, I'm gonna transition to my desktop. Give me a few seconds so that I can stop sharing this screen. And hopefully you can see my desktop screens here. All right, can you see my screen? Okay, awesome. Okay. So, okay, WebEx interface, go away. Wait, I cannot. Okay, it's gone. So over here, I have some a little bit of starter code. I'm gonna show you three things. The first thing is the quicksort function that I mentioned earlier. That if you have function pointer, you can play around with using that and point to the function, right? So I will create a function that compare two values A and B. So this is basically what we're gonna show here. How do you build a comparator? Any question about this line? So what is this? Can someone tell me what exactly is this? It's a function pointer. What is the type of the input of my function pointer? Yeah, it points to the function that takes in two inputs, right? Both inputs are a constant void type. It's a pointer to something. And the type of that something we haven't specified yet because Quicksort will use that. And it returns an integer, the same as the function signature of this function, right? So typically how Quicksort do things is, oh, this is basically to be safe, right? The const void. What does const void mean? It means I cannot modify the value, right? It's a constant value. I basically try to ensure, yeah, it's final. I mean, my function would not do anything with them except for what? What does this function supposed to do? Just compare, right? When I compare something, do I modify the content? No. So I can do this. If, right, how do I compare A and B? So basically, this is what I want to do, right? But is that going to be enough to make sure that this works? What's missing? And yeah, your answer is totally correct. It's not enough. So what do we have to do? Type check. Yes. Because why type check? Why type check? So what's the type of A? I guess what's the type of star A? Does it have a type? So does it have a type? By type, I mean, is that an integer? Is that a character? Is that a double? Is that a floating point? Right? So without the type check or type casting, avoid data type C will be like, okay, some data type, I don't know it. So how can I compare? So what do I have to do here? I have to cast A, right, into what? From void pointer, I should cast it to int. Is that int only or int pointer? Because A is a pointer to integer, right? A is a pointer to integer. So I want to cast A into not integer, but to integer pointer. So I have to do this. All right, so I'm gonna copy and paste because I'm lazy, right? And let's compile. Now the result is sorted, right? As you can see here. So if I don't do this casting and I change it to just integer, what would happen? So let's compile and see what will happen. It would yell at me basically. So let's actually go through this together, right? Let's go through this together. What does the error say? What does the error say? So what does this mean? Warning, cast from a pointer to integer of different size. What's the type of A? What's the type of A? It's a pointer. Oh. That works too. So that's a great question. That's a great question. And that works too. The key here is I cast it as void star because if I do that, I can just cast things and don't change the function signature. Don't change the function signature. I'll show you something. Actually, let me show you something. Uh, so let's save that question for later. But now A is a pointer. I want to cast a pointer to integer. So you would say, hey, warning, you're changing the data type from pointer to integer. Is that really what you want to do? Right? Warning, typically it means that your code might have bugs. Read them so you know exactly is that is that an okay warning that you can let it pass, or is that not okay? Error means I don't know what you're trying to do here. Why does it say that? I see star, right? Star mean what? I want to dereference. I want to dereference. I cast A into an integer. Can I dereference an integer? No, right? That's why it's basically yelling at me. So we need to change back. Uh, in pointer. Now, quick question. So if I want to flip this over, this is very sorting by smallest to the biggest. What if we remove the star over here? You mean here? You can try that. So what if we don't remove the star? We would complain. Anyone wanted to guess? Like, is that gonna complain? Does GCC will it complain at me? So yes, no. Just take a guess. I'll hit enter. It won't complain, but it will be weird. Why is that the case? What are you comparing? You're comparing the memory location, right? So anyone want to bet on what's the resulting array? We would get sort, or we would look the same, or what will happen to them? Nothing will be done. Why is that the case? So let's actually confirm, right? 1, 3, 2, 8, 5, 32. If you look at this result, right, is the same as this result. Why is that not doing anything? QSource actually get called, right? But instead of comparing the value, you're comparing the index. So yeah, exactly, because your array is already sorted by the index. A of 0 is going to be less than A of 1, right? So if I do something like this, so if I want to sort from greatest to smallest, one thing I can do is to flip the sign. QSort, if I return, basically QSort asks for the comparator. If A is greater than B, return 1. That means that you want to sort from smallest to the biggest. You want to sort from the biggest to the smallest, you flip the sign. If A is greater than B, that's -1. If A is lower than B, that's 1. Anyone want to take a guess if we run this, what would happen? It reverse, right? It reverse your array. It is gonna reverse your array. Everything is now reversed because your array will be printing from A9, A8, A7, A6, A5, A4, A3, A2, A1. Okay, so let's change it back. Actually, let me ask you one more question. What if I do this? Will it complain at me? I first dereference and then I cast this. Oh yeah, so that's definitely a better way to just reverse your array. I don't think you have to do sorting, right? You can use a linear algorithm that would take in all, finish in all of n. So that should be a faster way. Will this give you the same result as previous? It's giving me warning. Why is that the case? Why is that the case? What is A? What is the type of A? Here. A is a const void star, right? So you dereference it first, so it's like void data type, right? And you try to cast that to int star. So the order of the star matter. When you cast, make sure you cast this thing you want to cast is next to the data, the variable that you really want to cast, and make sure the data type match. Make sure the data type match. So in this case, right, because we're flipping the order, you should see the result that are in biggest down to smallest, right? So we can play around with this a little bit. Yeah, so that's the next thing I want to play around with. So what if I want to do this? Let's actually try. And because I'm lazy typing, sorry. I want to just copy the old one back. Let's see if this works, right? What does it say here? So let's just decrypt the warning. It's warning, so I can run. So let's actually run, right? It works. It works. But why does GCC give me this warning? This is a type of warning that um, can work, especially if you know what the function is trying to do. But the warning say what? What does QSort want from you? So let me, yes, exactly. So if you look at QSort in C, so I'm basically opening up this function. You see my screen? That are way too small. Let me zoom in. So this is the definition of QSort. It first takes your array, the size of your array, and the size of each variable in your array. Then it takes in this function that should have this format. It's a function that takes void star, const void star, and you compare them and return integer. Compare them and return integer. So let me go back to our screen. Oh, no, showing up, please. Here. Okay. So basically what it does is give you the warning is this is really what you want to do. Because my definition of QSort is supposed to take const void star. And to make sure that's the case, you basically have to declare the function that match the type, right? What's the beauty of this? It basically allow you to cast inside the comparator function. Cast the type inside the comparator function, right? Another way you can use QSource is you can basically do this. Instead of throwing function pointer, I think you can do this as well. Yep. So you can basically pass in a function name and you're done. So in that case, let me do something like this. So I want to make sure I have two functions. It's actually much safer, right? To make sure the functions that you pass in match exactly with what you're expecting. So this is basically for safety check. Warning, typically warning in your code means something are not safe. Something might go wrong. Something might go wrong. So these allow you to basically have the safety check that, hey, it's the same type, right? It's not just to silence the warning. It is used to make sure it match with the function definition exactly the way it's supposed to be. Why is that the case? Imagine you work in a large team, right? You build a function and someone else on the other totally different building use your function and doesn't match the type of input. How can you communicate that? Hey, is that correct? Is that not correct? The function definition and the type associated with the function is the way you can communicate. A warning is there basically to make sure hopefully there's no bugs, right? Hopefully there's no bugs. When you see warning, double check what's going on. Double check what's going on. In some cases, it's fine. In some cases, it's fine. So what if you want to sort the array twice, right? If we want to sort the array twice, array large, I guess small to large. I sort it once and print it from small to large, and then I do it again. But now I want to do it from large to small. Can I do this? Basically, I first make sure the comparator points to the function that will give me small to large. And then afterward, I want to have another quick sort, but now it's from large to small. The only thing I do is I call the same function, but now the function pointer points to a totally different function here. What will happen? Oops. I copied the function and it didn't change the function itself. My bad, guys. I need to change the function so that it's actually sort from small to large. Right? So now you can see, you can use the function pointer to dynamically change the function that you're pointing to. So in that case, if you have one comparator for comparing character, and then the other one for comparing integer, the other one is comparing integer but sort in a different way. You can build three different functions, use the same one function pointer for all of them. Any questions so far before we move on to a vector add? So I pre-built this vector add a little bit so that we don't have to, so that I don't have to type in saying, hey, A is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What do you mean when you cast for compare? Do you mean inside the compare function? Let me go back to QSource. Which part? You mean here? Yeah. So that doesn't work because A is a pointer. So you first need to say, hey, it's gonna be an integer pointer, and you dereference. Because the type of A is is a pointer to void, so you want to change that to a pointer to integer. So the question is when we cast, right? When we cast, can I just do int, right? And then store it? That wouldn't work because when I dereference, I already got a void, right? Now let's do vector add here. So A is 1 to 10, B is 2, 4, 8 is 2 to the n, basically 2 to the n, from 2, 4, 8, 16 up to 10, 24. C, right now initialize to 0. I can initialize my array this way, all right? Most of the code here is just to print what's A, what's B, and what is C. So if I do nothing, well, I guess let me comment this out. If I do nothing, it should print the initial value, right? What I want to do is to write a function that add my array together. What do I put in based on the function signature here? Right? I want to add A and B into C. Is an array, is an address already, right? So what do I put in here to add them together? I'm going to start from I equals 0 to size, right? What do I do? What do I put in here? Someone help me. I think you have way too many. Either you use A of I like this, or or you can do the A plus I and then the reference. Both of them should work. And now we got our results, right? Any questions about vector add before we dive into matrix addition? And that's where the majority of the confusion should come in, I think. Yes, A of I would be a reference for you because you already give them the index. But be careful when you use A of I. Make sure that index I doesn't go over your array. Doesn't go over your array. All right. Any other questions based on the code here? Oh, you mean what if I malloc, right, the results and then do it in there? That works too. That works too. Just make sure you free at the end when you're done using that. Like when you malloc, don't forget to free. That's all. All right, so metric add. First thing first, because this is likely to be a little bit annoying, I'm gonna have this define. Pound define basically means that I'm gonna have a new definition. Whenever I see the word debug, I'm gonna replace the word debug in my text with this number at the end. This is a pretty handy trick. You can do constant define to some value, right? Over here, I say if debug It means that if I have a bug and want to print something, I will make sure print right here, right? So this first function do nothing except for I take input metrics and the size, right? I take the input metrics and the size A, size X and size Y, and then I print them. I print the metrics. The other function is I want to add the metrics together. I want to add A and B into results based on the size of the metrics. And again, as usual, I initialize the array, right? I initialize the array. A is going to be 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5 row. B is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5 row. And I want to add them into C. Let me comment this out because I can assign the value earlier. So what do I do here? What do I call? I want to do this function metrics add, right? A, B, and C. What do I do? How do I add them together? Yes, I'll do int I and j first, right? That will be the index that go to loop around exactly, right? So you would loop around each element of A and B so that you can add them into results, right? So basically this is what you want to do. For, right? I equals 0, I is less than size of X, I equals plus. And what should the result be? So that's our first level, right? Results plus I. What is the next level? What should that be? What do I do next? What is the type of result plus I? Yeah, so you plus J, right? Oh, oops, my bad typo. You plus J. Is that all? Is this what we want? Is this entire thing is what we want for the results? Or am I missing something? What's the type of results? Is a pointer to what? Pointer to what? Pointer to pointer, right? How many times did I dereference here? How many star that are circling around on top of your head? No, I'm joking. How many star did I use on this line? I dereference only once, right? So what am I gonna get if I dereference only once? You get a pointer, which is not what we want. We want an integer. So what do? We add another dereference so that we get a pointer. Same thing here for the A and B, right? Hopefully that's correct. And let's see if that's correct or not. See if that's correct or not. So let me, it will give me a little bit, quite a lot of warning, actually. It's a, hey, it's incompatible pointer type. I want star, but I give you the array of integer. So let's try to run this. You're gonna get segmentation fault. You're gonna get segmentation fault. So let's debug this together. Segmentation fault is when you have illegal access. Somehow my code is wrong. Somehow my code is trying to dereference some illegal location. Okay, so let's go through that. First thing first, it basically seg fault starting from this function. If you look at that, let me show you this. GDB, right? Basically, I'm going to GDB and then run. It would show me the location of my seg fault The location of my seg fault is the what function? Basically, the what it say here is, hey, I print A, right? And then I see seg fault. I see seg fault. And it's seg fault at a function called print metrics. And here's your input. The input to my print metrics right now is A. Obviously, I want to print this array. The size of X is 5. The size of Y is 5. And the line that triggers seg fault is this. A plus I plus J, right? A plus I plus J. So let me print I is 0. Print J is 0. So what does this mean? I somehow cannot access this location. I somehow cannot access this location, right? See? Somehow I have A, which is the input, which is your 2D matrix, but I cannot access that memory. I cannot access that memory somehow. Okay, I'm gonna stop and quit GDB to show you what's going on. So to do that, let me enabling the debug part of the code so that it prints. Well, I'm gonna stop it from doing anything because I know that it starts from the first iteration is already wrong. So let me not do anything, right? And I just want to print what happened. What I'm printing here is, first of all, %x is printing hexadecimal number. %x would print in a hexadecimal format. So what am I printing? I'm printing the value of A, the address at A0, the value of A0, and the address of A00, the address of A00. And I'm gonna print the same thing here before the function call, So if I pass everything here correctly, I should see the exact same number, right? So let's see if that's exactly the same number. It's not, right? Address of this is, let me clean up the code a little bit. So I'm not going to do anything except for calling print metrics, and there's something wrong with my function call. So in the beginning, outside of my function call, this is going to be in print metrics, right? So outside of my function call, address of A0 is this value. Value of A0 is this value. Address of A00 is this value. And then A0 is equal to the value 1. A of 0, these are the same values here inside print metrics. Yes. Value of A0 is 1. Why is that different? Why is that different? I pass in my array. It's a static array. It's a static array, right? But each item in my array, in my 2D array, it points to this guy, right? If you dereference the memory, these flat, right? These flat memory, it's not a pointer. What goes in there is what? What is the data type here? What is the data type of this A55? It's a pointer of integer because you got this flat, right? 25 item in your main memory starting from item 0. Starting from item 0. So when you go in here, that's why A of 0 is 1, because it's 1D, but it's just long. It's 25 items long, but it's 1D. A of 0 is already point to the number 1. So when you dereference that, you're trying to dereference address at location 1, which you did not own. Right? Basically, what you're going to get out of this is essentially, this is basically what you have. A of 0 is going to equal basically something like this. 2, 3, 4, 5, 6, 7, 8, 10. 2. Oh, well, because it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, so we're going to have this 1, 2, 3, 4, 5, right? You got what I mean, right? Basically, I will have this flat 1D space that consists of 25 items, starting from the first item to the 25th item. You cannot dereference that twice. So to answer, will this work? No, it doesn't work. What do I have to do instead of this is I can do 2D array. So what's the first step? I need to malloc, right? What do I put in here? Is that int star or int? Int star, you're correct, thank you. So I do the same thing for A, B, and C. And what am I missing here? Now I malloc the first level. I need to malloc the second level, right? A plus I equal malloc. What is the type here? Is that integer star or integer alone without star? Int, yep. And we do the same thing for all A, B's, and C. And then before I forget, what do I have to do at the end? I need to free them. Yes, thank you. So I should be doing this. I cannot test them somehow. Let me copy again. Yank S here. This should be done at the end, because first you need to loop in and free. Oh, free. Yes, obviously, yes. You can change the function signature on top over here so that it becomes, I believe this should work. This should work. But this example, I kind of want to show you basically how to use the 2D arrays that are dynamic. Sorry about there's a question on the chat to say, hey, but can we just use the typical like static 2D array as an input? The only part that might not work well is when you store the results back. Because if you do this, how are you gonna return results? So let me ask you this: if I do this, how can I return results? Because after this function call is over, result is gone, right? Because you finish the function call, result somehow well C would deallocate that, so you cannot use it later. And first, to clean things up, I changed debug to 0. I'm not gonna debug them anymore, and see if I miss anything. Yeah, I think that's all. Huh. You mean basically you mean if I do this, right? Just to double check that we are on the same page. Yeah. So in this context, right, what happened is this function call will generate, say, the 5x5 input, right, for results in this function, inside this function, when you call the function. So over here, right, over here, basically results access. And toward the end, over here, results access. What will happen at when I'm done with this function? What would happen if I'm done with this function? Result doesn't exist. Yes, thank you. Sorry, those this name result as a variable outside of this function is gone because of the scope. The scope doesn't cover anything outside of this function, so the result is gone. That's why when you want to pass something out, you would use a pointer. Why is that the case? Because in this case, result has been malloc inside the main function. That area has been allocated. It won't be gone until you free them. It won't be gone until you free them. So hopefully, does this clear up a little bit of this confusion to make sure that we are all clear and on the same page? Oh, it's a pointer. That's correct. It's a pointer, but it's being allocated inside, like it's being statically allocated when you call that function. And it's gone right when you finish calling that function. So it's a pointer, that's correct. The issue is the fact that that allocation, that allocation is gone when you finish calling the function. So it's true, it's a pointer. It's just a matter of like where can I still access things in there. The problem with the earlier approach, if you use the bracket array, is when you finish the function call, allocation is gone because C knows that okay, I finished that function, so everything local to that function is gone. I'm gonna deallocate them. So that's it. Is it a little bit more clear or is it still confusing? But these are awesome questions. What if we return? What if we return? You return a pointer. So if you return a pointer, what are you gonna get back? You get the address, right? So you're gonna get the address back. So everyone with me so far. So the question is, well, in that case, can I return results? If I return a pointer, I'm gonna get back an address. The issue here is if I get the address, do I have the ownership to that address after I call the function? So it would work inside the function, but once you finish calling, right, the program doesn't own that anymore because C would kind of deallocate that for you because you do this statically. The way you can do this is to do this dynamically where you malloc, right? When you malloc, that whole range of address will be yours until you free them. Until you free them. Is it more clear? Basically, you pass thing by reference, but if you modify static array, right? Once you're done with the function call that static array, even though you have the address, but the space inside that, the actual space in the main memory is gone. You did not own that anymore. So you will get the address, but you will not get to access them after the function call. Because basically you did not own that anymore when you're done. Any questions? Okay, perfect. Oh, sorry. So let's compile this. And there's an error that I did not foresee. So let's I did not see the text for the error. The way you can do this is if I want to compile and save the text in the file, I can do redirection. Oh yeah, sorry. Let me go back to the code. Let me first check the what's wrong with this error. Oh, undeclare I. Okay, stupid of me. You mean which part? You mean here? The A by A plus I. So the question is, what is store A plus I? You got confused about that. I want to make sure it's that line or is that the other line? In the loop. Okay. So A, alone A is the pointer to pointer. It's the pointer to the first level of array of pointer, right? A plus I would give you the i's pointer in my array. I think the best way to do this is probably switching back. So let me switch back to my screen on the desktop. On my laptop, my bad. Do you see my screen? So we have star A, right? Star A. Basically, this means that I have my array of pointer. This is basically A. This is basically A plus I over here, right? What is the type in this A plus I? What's the type inside this A plus I? Yep, it's a pointer that points to another array, right? So that's what star A plus I do. Star A plus I would give me this location. I go A and then plus I, and then I first dereference that so I can point to my second array. So is it more clear with this visualization? Okay, awesome. So I'm gonna switch back to my desktop. I need to switch over and stop sharing this. Now I need to share this. Okay. Now I hope I fixed all the bug in here. And we got the results. All right, so this is basically how you can fix the code earlier. Now we have the proper metrics addition. Most of the time we're spending trying to figure out what happened when you dereference thing, right? Any questions, any lingering question before, whoops, I guess the screen doesn't show up, is it? Here. So what I did is just compile and run, so you can see the results. So last thing we are going to do today, we have the in-class exercise. We have about 30 minutes. We're going to switch over to Discord, all right? We're going to switch over to Discord and finish the in-class exercise. What we want to do is to do metrics transpose. So make sure we write that function and you're comfortable using 2D array, using pointers, all right? Any question before we switch over to Discord? Any last minute questions?